Hello everyone, today's video we are going to solve this 36 number problem asked in CSIR NET June 2019. It's another question from complex analysis, and in this problem they have given us two data, and depending upon these two data they are asking which of the following is going to be true. So let's try to solve this question with a very systematic manner so that you can tackle this kind of problem in the exam. They have given us function f from c to c, which is entire. This f is entire, and extra information is given to us, which is f of 1 by z, and take the limit as z tends to 0 and you will have infinity. This condition implies that z is equal to 0 is pole of f of 1 by z. Clear? That immediately implies z is equal to infinity is pole of f of z. Very fundamental result from complex analysis. Okay. Whenever z is equal to 0 is pole of f of 1 by z, that implies just the reciprocal. Z is equal to infinity is pole of f of z. Clear? So these two things we have in our hand. Okay. Now to solve this problem, you need to have a basic idea of a theorem from complex analysis, which says that the main idea of that theorem is something like, if your function fz is entire and at z is equal to infinity, or at z is equal to infinity, fz has pole of order n. In other words, z is equal to infinity is pole of fz with order n. F is entire and this condition hold, then these two will together imply that your fz must be polynomial of degree n. This is a theorem. We are going to use this theorem to solve this question. Okay. Now in the problem they have given us these two data, and these two data together implies that your fz must be a polynomial of degree n by using that theorem. Okay. So your fz will be of this form: a0 plus a1 z plus a2 z square plus so on n z to the power n. Okay. Immediately it says that your first option is false, because in the first option they have given us that f is constant, but it is never going to be constant. Alright. Now come to the fourth option, where they have given us that f is necessarily nowhere vanishing, but your fz is something like that, and if you simply set fz is equal to 0, then it will give a0 plus a1z plus a2z square and so on, an z to the power n is going to be 0. And by fundamental theorem of algebra, you can immediately say that this fz will have 0, even at most it will have at most n zeros, n zeros. That means your fz is going to be vanish at at most n points. Okay, so the never vanishing, this term is not going to be true. That implies your fourth option is false. Alright, now come to the second and third option. You can immediately check that it will have at most n zeros by fundamental theorem of algebra. So no question of getting infinitely many zeros. Thus your second option is also false. The remaining option, that means the third option, is the correct one. Okay, but one normal question may come in your mind about the given condition, which is they have given us simply this data. Simply this data is given to you. That means z is equal to infinity is pole of fz, no problem. But what is the order of that pole? No question. In fact, no information is given on the order of that pole. Okay, just for simplicity, we are taking the order of that pole is going to be n. That assumption, on that assumption, we have taken that fz is going to be of this form. Okay, if you suppose that your z is equal to infinity is going to be pole of order 2, then you simply take fz is equal to a0 plus a1 z plus a2 z square. Then that will do the same work for you in this question, and you will get the same kind of options or the same kind of elimination of options you will get from that point of view also. Okay, thank you.